How does immunotherapy target neuroinflammation in Parkinson's? Imagine a tiny army fighting inside your brain, trying to keep it healthy. In Parkinson's disease, this army faces a tricky enemy called alpha-synuclein, a protein that can misfold and form harmful clumps. These clumps trigger the brain's immune cells, like microglia and astrocytes, to become overactive. This overreaction causes inflammation, which can damage healthy neurons and worsen symptoms. Immunotherapy aims to help control this internal battle by guiding the immune system to respond more effectively and safely. One way immunotherapy works is by targeting the alpha-synuclein protein itself. Scientists are developing treatments that use antibodies, special proteins that can recognize and bind to misfolded alpha-synuclein. These antibodies can be administered passively, meaning they are given directly to the patient, or through vaccines that stimulate the body to produce its own antibodies. When these antibodies attach to the toxic protein, they help the brain's cleaning systems remove it more efficiently. This reduces the amount of alpha-synuclein that can activate immune cells and cause inflammation, helping to protect neurons from damage. Another key approach involves calming the immune cells that have gone into overdrive. Microglia are like the brain's first responders, but in Parkinson's, they can become overly aggressive, releasing harmful substances like cytokines and reactive oxygen species. Immunotherapy aims to shift microglia from this harmful state to a more protective one. Some strategies focus on enhancing regulatory T cells, which are immune cells that suppress inflammation and promote healing. By boosting these cells, therapies can help create a more balanced immune environment in the brain. In addition, immunotherapy can interfere with the signaling pathways that lead to inflammation. When alpha-synuclein activates immune receptors, it triggers pathways such as NF-kappa B and inflammasomes like NLRP3. These pathways produce inflammatory molecules that damage neurons. By blocking or modulating these signals, immunotherapy can reduce the production of harmful cytokines like interleukin-1 beta, interleukin-6, and tumor necrosis factor alpha. This helps to calm the inflammatory response and protect brain tissue. Some approaches also consider the role of the peripheral immune system. Changes outside the brain, in the immune cells circulating in the blood, can influence neuroinflammation. Certain immunotherapies aim to modify these peripheral immune cells so they are less likely to promote harmful inflammation once they enter the brain. This dual focus on both central and peripheral immunity offers a comprehensive way to address neuroinflammation in Parkinson's. While these strategies show promise in laboratory studies and animal models, translating them into effective treatments for humans remains a challenge. Clinical trials are ongoing to determine which immune targets work best and at what stages of the disease. The goal is to develop therapies that are safe, effective, and capable of slowing or stopping the progression of neuronal damage caused by inflammation. In summary, immunotherapy targets neuroinflammation in Parkinson's disease by neutralizing toxic alpha-synuclein, calming overactive immune cells, blocking inflammatory signals, and potentially adjusting immune responses outside the brain. These approaches aim to create a healthier environment in the brain, protecting neurons and improving quality of life. As research continues, scientists hope to refine these therapies to offer real hope for those affected by this complex disease. Always consult healthcare professionals for personalized advice and treatment options.